Welcome to Brain Vision.
In problems 109 and 110, we're asked to look at find the maximum minimum tension developed in the cable that is supporting a pipe, and that pipe has a mass of 1,500 kilograms per meter. So the cable has supports at the same height on both sides, and let's see, this should be B, let's see here, let me fix some of these things here. B sub x, B sub x, B sub x, B sub x, and B sub x. Alright, so we have this cable. I'm going to set the origin to 0 and call that point C here at the minimum, where it's at the lowest point. Because of the uniform load here and then the supports being at the same height, the minimum will be at the middle. The equation describing this curve is just 4ya x squared over L squared, where ya is the height of point A above the origin. You could also use yb here. The horizontal load is L squared W naught all over 8ya. We're told ya we're given is 3 meters. Then we can figure out the tangent of these things, the tangent of the tangent of the angle that is made by the tangent to the curve and the horizontal is 4ya over L. So we can just figure out by taking the slope of this and putting the length L here. I really probably shouldn't call this L, but L is the distance between the supports, not the length of the cable. But just note that that is not the length of the cable. Now, we are asked, and in this problem it's given to be 30 meters. So we're asked in problem 109 to find the maximum, and that occurs either at this point or this point. Because cosine is an even function, so that will be their maximum. We can just take the absolute value of the angle here. Now we have that angle at we can find that because we know what ya and we know L, so we can find theta A. Plugging everything in, we know what this is. Just remember to multiply by G because we're given as a mass per unit length. In the end, we come up with that the tension at either of these points is the maximum, and it is 594 kilonewtons. So that's the answer for problem 109. And for 110, the minimum is just the tension here at the center, because that's when cosine is the largest, and that is 1 for this case. So that's simply the value here, and if we plug in the values that were given in the problem, that comes out to be 552 kilonewtons.